Lesson 11, a special rule of 0 in factoring. We're going to go through the opening exercise and through a few other problems, but basically this reminds us how to factor, basic factoring. We're going to go much deeper into factoring soon, and to understand what it is we're factoring and to achieve. So we're just going to run through the examples and exercises and see what is there. So it says find all the solutions to the equation. So what things could I put in for x that would make this equation equal to 0? Well, we're not going to sit here and guess. What we're going to do is we're going to take these pieces and we're going to factor them. So we're going to find out what two things multiply to equal x squared plus 5x plus 6. So if you remember anything about factoring from Algebra 1, that's great. If you don't, we'll remind you of what we're going to do. So the first thing we're going to do is we're going to take a look at this x squared right here. And we're basically going to split it up. Put one of the x's here and one of the x's here. We do that because we know that x times x is x squared. So that gives us that placement and effectively splits that up. The next thing we're going to do is we are going to focus on this 6. We want to think of something that multiplies to equal 6 and adds to equal 5. So this technique only works because the coefficient in front of this x squared is a 1. For the ones that are not a 1, we'll talk about other strategies when the time comes in those sections. So but anyway, if I think of something that multiplies to equal 6, let's say 2 times 3. Well, it turns out that 2 times 3 is also 5. So I can put a plus 2 here, and I can put a plus 3 here. Now, how do I absolutely certainly know that this is going to give me 5x? Well, you can do a little mental check. I'll write it, but you would multiply the inside right here, and that inside is 2x, and you multiply these outside values, and that is 3x. If these two add up to equal the number in the middle, which is 5x, that is the combination that you are looking to get in this particular piece. So we'll take this off for now. We'll do the same thing with the next one. We're going to open up a set of parentheses and we're going to factor. Again, we see our x squared, so we're going to split it up as x and x. Something that multiplies to equal -4 but adds to equal -3, right? So something that multiplies to equal -4 and adds to equal -3. You have to be a little bit more careful here because you're dealing with negative numbers. But it turns out it is -4 and +1. It does not matter which one you write first. You could put the +1 in this one and the -4 in this one. It does not matter. Again, if we wanted to check to make sure it was accurate, we would multiply the inside to get -4x. We would multiply the outsides to get +1x. And if these two results add up to equal the number in the middle of the polynomial, you have successfully checked it and you know it is correct. So we'll go ahead and take this off now that we know it has been checked. And so remember, our goal here started out to find the solution, so that's what we're going to do. We are going to find the solutions. To do that, what we're going to do is we're going to split all of this up. And we're going to set each one equal to 0. And then x plus 3, we set that one equal to 0. We set x minus 4 equal to 0. And we set x plus 1 equal to 0. And so we're going to get our results. We subtract 2 to this side, so we get x equals -2. We subtract 3 to this side, so we get x equals -3. We add 4 to this side, so we get x equals 4, and we subtract 1 to this side, and we get x equals -1. These are our solutions. Also known as, so we'll say also known as, aka the zeros. So why are they called the zeros, right? That brings up a good question. So to do that, we are going to bring up a graphing program, and we're going to graph these so you can see what we get. So our graphing program we're going to use is going to be Desmos. So we'll type in our problem. It was x squared plus 5x plus 6. And then we had x squared minus 3x minus 4. So this is what we get. Now if we look at our graph, let's see if we can do this. Makes it easier to see. Our zeros are here, -3, -2, -1, and 4. These were the solutions that we got when we factored our problem out and solved them. All right, so let's look at another one. Right, again, one more shot looking at that. If we look at exercise number 1, they say find the solutions to x squared minus 9 and x squared minus 16. So when you initially look at this, you say, well, wait a minute, it doesn't look like the last problem. But this is one of our special identities. Remember the difference of squares? So both of these are a difference of squares. So if you remember that identity, we're going to open up a set of parentheses for the x squared minus 9. We'll put x minus 3 in this one, and x plus 3 in this one, right? If you're sitting there wondering how did I come up with that idea, remember if you have the difference of squares, whoops, let's go back to that, there we go. The difference of squares says x squared minus a squared is equal to x minus a, and then x plus a. How do I know these are going to be 3's? Is because I can rewrite the 9 as x squared minus 3 squared. So then I know that translates to x minus 3 and x plus 3. Right, so we do the exact same thing with the x squared minus 16. So this will be x minus 4, and this will be x plus 4. So now we set each one equal to 0. So x minus 3 equals 0, x plus 3 equals 0, x minus 4 equals 0, and x plus 4 equals 0. So when we solve each one, x is equal to 3, x is equal to -3, x is equal to 4, and x is equal to -4. So those would be our solutions. Again, if we wanted to verify that with our graph, we can. So we'll take this one off. We can write x squared minus 9, and then x squared minus 16. These are our solutions: -4, -3, +3, +4. Looking at it from a graphical perspective. If you haven't tried that, this is, by the way, if you've never used Desmos, this is desmos.com. You can see that written in the browser up in this video. I'd recommend you go there, try it, typing this in, see if you can get this exact same result as well. If you press the little wrench up here, this is where all the settings are at. I like to use projector mode because it makes it a little bit easier to see, but you don't have to. See, it makes it less bold, or it makes it more bold. Okay, so this brings us to example number 1. Right, a bigger problem to look at. It says, suppose that we know we have a polynomial equation as such. So they give us this polynomial equation. We'll underline it so we can see it. This one right here. And then they tell us, well, what if we know that it has 3 solutions? So I'll give you a little hint. If we know it has 3 solutions, it's because the largest exponent here is a 3. So we are expecting to get 3 solutions. They tell us that all 3 solutions here are real, and that one of the factors is x minus 1. So we know that one is the case. Now, without going to the graphing calculator, let's take a look and see how we could solve this. So we know this one is a factor. If we know it's a factor, that means we can divide. So that means I can take and I can do x minus 1, and I can divide it into my quotient. 4x to the third minus 12x squared plus 3x and then plus 5. So what we're going to do is we're going to reduce this from a cubic family polynomial to a quadratic. The quadratic is going to allow us to factor and solve. So let's say x goes into 4x to the third, 4x squared times. So we put a 4x squared. So this times this is 4x to the third. 4x squared times negative 1 is negative 4x squared. We want to put our parentheses and put a minus sign. Remember, this is our long division. So this cancels out. Negative 12 minus negative 4 is going to give us negative 8. So we're going to write down negative 8x squared. Bring this term down so we have a positive 3x, and then we're going to do this again. So x divides into negative 8x squared, negative 8x times. So we'll write that right there. This will give us negative 8x squared, and then negative 8x times negative 1 is positive 8x. Put our parentheses. This subtracts. 3 minus 8 is negative 5. So we have a negative 5x. I'm going to bring down the 5, so we have a plus 5. So x goes into here negative 5 times. So we get negative 5x plus 5. And when we subtract, we get a remainder of 0. That also confirms that x minus 1 is a factor. So what are we doing with this now? So here's our quotient. 4x squared minus 8x and then minus 5. Let's clean that up. That doesn't look like a good 5. There we go. Minus 5. So we have this. And then in front we have the x minus 1. Now what does that mean? That means if I multiply these two, that's written in blue, that's going to give me the original polynomial equation, the 4x cubed minus 12x squared plus 3x plus 5. So the nice thing is now is this one, right? X minus 1 equals 0. I know that one of my solutions is 1. For this other one, I need to factor. So I'm going to open up a set of parentheses and I'm going to factor. Now, notice this time there is a number in the front. That means I could possibly have a 4x and a 1x, or I could have a 2x and a 2x. Both of those things multiply to equal 4x squared. How do you know which one it is? You don't. You have to guess and check and find out. But if you're looking for a little tip, You always want to pick the numbers with the least difference. So 2 and 2, the difference between those is 0, so I would go with that. And then I would expand my differences between factors from there. Here we have a -5. So something that multiplies equal -5 is -1 and 5, or -5 and 1. How do I know which one it is? I don't. We're just going to guess. Let's say we put -5 and a +1. How do I know if it's right or wrong? We're going to check. So we're going to multiply the inside. This is going to give me -10x. And then I multiply the outside. That's going to give me 2x. I'm checking to see if these two add up to equal the number in the middle, -8x. They do. -10x plus 2x is -8x. So once I have established that, right, then I know that it checks out. If it did not check out, I would alter my numbers up here until I get a combination that will work. But now that we know that it does, right, we can set each of these equal to 0. So 2x minus 5 equals 0, and 2x plus 1 equals 0. And so we solve this, so we start by adding 5 to the other side. So 2x equals 5, and then we'll divide by 2. So x is going to equal 5 over 2. You can write 2.5 if you want, but that's just an extra step. So now we're going to minus 1 to this side. So 2x is going to equal -1. And then we're going to divide by 2. And so x is going to equal -1/2. And again, you can write that as -0.5 if you want, but you're just adding an extra step to what we're doing. So those are our solutions: 1, 5/2, and -1/2. We're going to check that with a graph. So we're going to open up Desmos. We can close out this one. And again, if you have not tried this yet, try typing in the original function. So that would be 4x raised to the third power. And then minus 12x squared plus 3x and then plus 5. So if you move your cursor over little dots and you click it, you can see this is -1/2. This is 1. And this is 2.5 or 5/2. And so that graphically confirms that we found the solutions, or what is also known as the zeros, of this particular problem. So now we're going to look at our last set of exercises we're going to look at for this one. We're going to do exercises 2 through 5. It says find the zeros of the following polynomial functions, and it says state their multiplicities. Okay, so that's something new. So we're going to underline multiplicities. That implies that we're going to get the same answer possibly more than one time. And so we want to look at that and figure out what's going on with that and why and everything else. So if we look at these, right, this one would say x equals 1, or if we set each one equal to 0, this would give us a result of x equals -1. This would give us a result of x equals +1. And this one, right, when we look at it, it's a sum of squares. So if we attempted to solve it, right, let's just think about this one. X squared plus 1 equals 0. And we try to move this to the other side, we get x equals -1 with a squared here. To get rid of a square, we square root, so x would have to equal plus or minus the square root of -1. Right? We're going to put a question mark by that, because we can't take the square root of a negative number. So let's go and let's take a look at the graph, right? And let's see what happens. If we were to type in x plus 1, right, there's an obvious 0. If I was to type in x minus 1, there are these. And if we were to type in x squared plus 1, we would get this. And so we see these values here in this design. Now it turns out the answer to this, and I'm not going to go into it now, and you're not responsible for it now. The final answer for this is negative 1 with a multiplicity of 1. So negative 1 multiplicity of 1, and a 1 with a multiplicity of 1. This one does not have any viable real solutions, so we're going to leave this one alone. So if we look at this one, this says x minus 4 to the third power. Now, just for understanding what that means I've got x minus 4, x minus 4, and x minus 4. Now you don't have to write this out every single time. I'm drawing out a point. If I see this 8, that means I've got x minus 2, x minus 2, x minus 2. This 1, 2 is 3 of them. Here's another one, another one, another one, and let's just put another one right there. I've got 8 of them. If I was to solve every single one, I would get 4 3 times. So our answer is 4 with a multiplicity of 3. And then all of these negative 2's, if I solved every one, I would get x equals 2. So that would say, and we have a solution of 2 with a multiplicity of 8. Means it happened 8 times. So let's look at C. C says 2x minus 3 is written 5 times. Right, so that's not, we can write that out. 2x minus 3, 2x minus 3, 2x minus 3, 2x minus 3, and 2x minus 3. I mean, you don't have to write it out 5 times. I'm just reminding you that means this happens 5 times. We're only going to solve one of them, right? If we solve one, we add 3 and we divide by 2. So we know that x is going to equal 3 halves, or 1.5. How many times is that going to happen? 5 times. So we'll say x is equal to 3 halves with a multiplicity of 5. Now, this is why understanding this is important. Look at letter D. I really do not want to write 3x plus 4 100 times. So I'm literally going to solve this one time, and I'm going to say x equals negative 4 thirds, and I'm going to write with a multiplicity of 100. Then I can do this one. X equals 17 with a multiplicity of 4. And so that's pretty much what this lesson is about finding solutions and understand that multiplicities can occur. So that's going to wrap it up for this lesson. We're not going to look at exercises 3, 4, and 5. We're going to move you into the problem set at this time. Thank you.